Hi, this is Dr. Kurt Wohler for Sunrise Functional Medicine. The title of the short video is Teenager with an Unknown Mitochondrial Disorder. The disclaimer is for you to understand that this information is for educational purposes only. Now, the clinical history, this is a male teenager who is having worsening fatigue and worsening musculoskeletal weakness. Now, the clinical history actually goes back to when this individual was 8 years old. They were very active at that time, playing a lot of different types of sports. And there was a complaint of becoming more weak and tired overall. Now, this actually developed after a flu-like illness. And within 3 weeks or so of that illness, there was a major deterioration in his overall health. Vomiting episodes, for example, progressive weakness. And then even today, whenever he gets sick or is overstressed, his condition will worsen. And so the main health concerns is there is some type of what's called an inborn defect within the electron transport chain. And essentially, in quotes, actually coming from the medical records, the cells are not making enough ATP within most of, that is essentially most of the problem within the skeletal muscles. Now, progressive weakness, as I mentioned, this also manifests as poor exercise tolerance, so he cannot run or ride a bike, and even now is progressing with just difficulty in walking long distances, and then easily fatigued. So a lot of laboratory tests were done. From a conventional standpoint, there was evidence of an electron transport chain dysfunction. I'll show you what that is here shortly. But they couldn't quite locate exactly within the electron transport chain where there's a problem. But they know that there is some problem within the electron transport chain, and that is greatly affecting his mitochondrial function. There's been a lot of other tests that have been done indicating different types of imbalances, environmental exposures, mold mycotoxins, for example. And so what was done from an integrative standpoint was a couple tests. One was called the MitoSwab test. Now the MitoSwab test, which I'll show you a sample of here in a second, is a buccal swab that actually evaluates the activity within the mitochondria of certain types of electron transport chain proteins. So it has approximately an 84% correlation with complex 1 and complex 4 within the electron transport chain when compared to the gold standard of muscle biopsy analysis to essentially look at mitochondrial function. And the benefit of this test, again, we can obtain information from a buccal swab, which is much easier to get than doing a muscle biopsy. So this is this individual's MitoSwab test. So this is the first section of the test that's looking at something called citrate synthase, which is the first enzyme of the Krebs cycle. And then we have complex 1 where it says RC1, RC4. That's complex 1 and complex 4 of the electron transport chain. And what you'll notice is that complex 4 is actually elevated. That's thought to be probably some kind of compensatory reaction where the mitochondria at that point are trying to increase its activity to make ATP. But complex 1 is actually below the normal range. And so when we think of the mitochondria are these energy factories in our cells. There's thousands of mitochondria per cell within the high metabolic organ systems of our body. That would be our brain, nervous system, our heart, cardiovascular system, our muscles, for example. And then we have something called the Krebs cycle, also called the citric acid cycle. And then the final point of chemistry reactions is what's called the mitochondrial respiratory chain, also called the electron transport chain. And essentially, we're transporting electrons down these different protein complexes to make ATP, which is adenosine triphosphate. And so it turns out that complex 1 deficiencies is the most common point in the electron transport chain to become defective. So Unfortunately, complex 1 is the largest protein of the electron transport chain, which means it's the greatest point of electron leakage into the mitochondrial matrix. What does that mean? If we're not able to transfer electrons from one complex to the next effectively, then many of those electrons can leak into the matrix, the inner part of the mitochondria where there's a lot of oxygen, and that can generate reactive oxygen species, which can then damage the mitochondria. And so this is actually an area in this individual that is defective. Another point of great electron leakage potential is actually complex 3. So we have 4 main complexes, 1, 2, 3, and 4. And then the last complex, or I should say last protein, is something called ATP synthase, which is actually where ATP is produced. And so another aspect of this individual's Mito-Swab test was looking at complex 2 and the combination of a complex 2 and 3. And so his complex 2 activity was normal, but his complex 2 and 3, the combination was actually low. So he not only has a low complex 1, which is the largest protein complex of the electron transport chain, the greatest area of electron leakage. The second greatest area of electron leakage would be a deficiency of complex 3. So it turns out he actually has both areas compromised. Now, one of the things that can happen in many mitochondrial problems is a buildup of lactic acid. So we've all felt lactic acid, for example, when you exercise too much, that sort of burning feeling you get in your muscles, for example, is felt to be due to an increase of lactic acid. And there's many different reasons that lactic acid can be high. But an abundance of lactic acid can lead to something called lactic acidosis, which is a form of metabolic acidosis. And so the way to think of it is just too much acidity building up in the system. And that in itself is stressful. And when we have too much acids in circulation, it can deplete the buffering systems of the body, and that leaves the brain, the nervous system, the liver, the kidneys, the muscles just vulnerable to damage. And so over the years, this individual has had blood testing that has shown elevated lactic acid, again, over a period of time. So not only is there some type of problem in the mitochondria in making ATP, there is this persistent lactic acidosis. Now, another way of assessing lactic acidosis and other mitochondrial imbalances is through something called the organic acids test. Now, my personal preference is the organic acids test from Mosaic Diagnostics, which used to be Great Plains Laboratory. Now, this is just an example of an individual's section on the organic acid test from Mosaic Diagnostics that's looking at different mitochondrial markers. So we can see here elevated lactic acid. We see elevated mitochondrial markers, such as fumaric and malic and a few others. So there's a lot of data that you can pick up with regards to mitochondrial activity, other dysfunction, other imbalances by utilizing the Mosaic Diagnostics organic acids test. Now, in this individual's test, this young man's organic acid test, we do see an elevation of lactic acid, which correlates with many of the blood tests that he had done. And you'll also notice that there are some elevated amino acid metabolites. And one specifically I want you to focus on is marker 31, which is 3-hydroxyglutaric acid. And that marker at that level is actually very high. And so that marker is actually linked to a deficiency of an enzyme called glutaryl coenzyme A dehydrogenase. And the chemistry of this gets complicated, but the bottom line is that there are various pathways that metabolize certain types of amino acids. So lysine, for example, gets metabolized and gets converted downstream into compounds that can enter the Krebs cycle, essentially enter the mitochondria to help support energy production. And so when there's some kind of blockage or something that is affecting the flow of these pathways, we can start to see increases of some of these other organic acids. And remember, when we have elevations of a wide variety of organic acids, that can be a contributing factor to metabolic acidosis. So from a genetic standpoint, values greater than 60 millimoles per mole are generally seen in what are called glutaric acidurias. And there's a couple different types, glutaric aciduria type 1 and type 2. And essentially one of the things that's done in these types of conditions is to limit the intake of lysine within the diet and also to give carnitine supplementation to try to help improve the overall status of this biochemical pathway. Well, another aspect of this individual's organic acid test showed some elevated ketone and fatty acid oxidation markers, specifically the fatty acid oxidation markers. So we can see here elevations of ethylmalonic, methylsuccinic, and subaric. And what this indicates is that there is some other problem happening in the way the cells metabolize fat. So we metabolize glucose, protein, and fats to help get energy from those food substrates. But if we have problems downstream of the biochemistry that can't make that happen, we can start to build up these organic acids. And so I just listed here this carnitine synergy supplement. There's many different supplement companies that have carnitine, but the bottom line in this particular case was the implementation of carnitine to assist in overall mitochondrial function. And what makes this case challenging is that there are many overlapping problems of multiple point deficits within the mitochondria, specifically the electron transport chain. As I just mentioned, we have documentation of low complex 1 as well as low complex 3. And then on top of that, there appears to be some problems in metabolizing lysine. Okay, that leads to a type of glutaric acidemia. So all of that has a stress-inducing effect on overall metabolism, energy production. And then because the musculoskeletal system is one of the high energy system demanding organs in the body, this is the primary area that's affecting this person, is just overall fatigue and musculoskeletal weakness. Now remember also, because there is compromised mitochondrial problems, and we've got a deficit in complex 1, a deficit in complex 2, the two greatest areas within the mitochondria for electron leakage, there is also an increased production of oxidative reactions, and they themselves will further damage cellular function, organ systems, as well as mitochondria overall. So one of the things that was done to help support mitochondrial function as best as possible is implementing targeted mitochondrial support supplements. So ATP 360, for example, is a comprehensive mitochondrial support product. L-carnitine, B vitamins, CoQ10, also supportive. D-ribose is an interesting compound, helpful for mitochondrial ATP production, particularly within the musculoskeletal system. Riboflavin, which is vitamin B2, is actually needed for complex 1 and complex 2 function. Sulforaphane, which you actually can get through broccoli, for example, aids in antioxidant support. Liposomal C, liposomal glutathione, for example, also have antioxidant properties. And then the interesting aspect of melatonin. So liposomal melatonin actually assists in electron transport chain activity. It also has its own intrinsic antioxidant properties and downregulates something called aerobic glycolysis. So when the cells of the body are stuck in this aerobic glycolysis, that in itself can drive more lactic acid formation. So this is a very comprehensive sort of targeted mitochondrial support program that was designed based on the clinical history, lab testing, including the lab testing of the organic acid test from Mosaic Diagnostics and the Mitoswab test from the company Mitoswab. And so the combination of the organic acid test and the Mitoswab profile, or you can call it a Mitoswab test, is a very powerful combination that helps in the clinical decision making with regards to mitochondrial dysfunction. And it picks up in many regards information that is really not available sometimes through other types of conventional medical testing. So in a complex situation like this, these two tests are very important, and this information too with regards to this test can be applied to other types of health conditions. If you'd like to get a more detailed analysis of this particular case, you can go to my Substack. You can join my Substack. It's free. You can go to drwohler.substack.com and read about this case of the mitochondrial disorder in this 17-year-old male. For more information about our clinical practice, you can go to my Sunrise Center. You can also email with questions at scmedicalcenter@gmail.com. Again, I'm Dr. Kurt Wohler for Sunrise Functional Medicine. Thank you.